you don't want your house to burn down, then you need to build one of these. But hey, in all seriousness, do not replace your home or business fire or smoke alarm with one of these. But what this is, it's a fun do-it-yourself beginner breadboard project. I'll show you real quick all the components, how they work, and just how easy it is to build your own long-distance fire detector. With that said, let's head on over to the workbench and get started. First things first, in order to build one of these sweet fire detectors on a breadboard, you're going to need these components. To start off, you're going to need to power this sweet breadboard project. For that, you'll need one of these handy breadboard power supplies, or you could also use a 3.7 volts DC battery pack. You're also going to need an IR LED. Now, this is not your typical red, green, or blue LED. These are infrared receivers. For resistors, you're going to need a 1000 ohm resistor, a 10,000 ohm resistor, as well as a 470 ohm resistor. Now, not needed, but does help filter the circuit, a 100 microfarad capacitor. And for light indication, we're going to use a red LED. Now you can use any color, but I recommend red. You're going to need a BC547 transistor. For the fire alarm tone, you're going to want to use a 5 volt active buzzer. And that's it, folks. Other than that, it's just your typical breadboard wires. You could pick up these breadboard wires on Amazon. I'm going to throw links to everything we talk about today in the description below, so check that out. You can pick up everything for this project for under $15. The first component I'll put in, because I like to work left to right on my breadboards, is the active buzzer. Now you'll see the positive sign there is on my left, and positive will go to the left side of the circuit. I'm going to start up around number 10 on my breadboard, plug that in left to right. Now you don't want to plug it in up and down because of course it would be shorted out, so left to right. The next component I'll put in is the red LED. Now on these lead components, usually the long lead is going to be your positive lead, and we'll have that on the left side as well, just like the buzzer. So I'll place this about 4 or 5 rows over to the right of the buzzer, so positive on the left side again. Next we'll place our BC547 transistor into the circuit. Now you'll notice transistors have a flat side and a round side. The way I'm going to place it into the circuit is with the flat side facing me. A transistor works pretty much like a switch. You're going to have a low voltage on the base leg of the circuit, and once the current is increased in the circuit, that actually initiates the switch inside the transistor to open and allows current to flow through it. I'll go ahead and place it into the circuit on the same row a few columns down. Now you'll see I have my transistor installed, again with the flat side facing you. Okay, first up for the resistors, we have the 470 ohm resistor. Now this does not matter which side you put it in. These are non-polarized resistors. So we'll go ahead and put in one lead in the positive side of your LED. We're going to come across the board over here in this direction. Matter of fact, we'll keep it just about parallel on the columns. Now this gap right here in the middle of the breadboard allows us to keep it in the same column, but it is not shorted together. It is not connected across this gap. Okay, next up is the 1000 ohm resistor. Now this is going to go on your center lead of your BC547 transistor. And again, we'll come straight across the gap. Now, when you're doing this at home, it doesn't have to be in the exact holes I'm using, as long as the setup is the same. And remember, never plug one component in on the same column on the same side of your breadboard, as it will be shorted together. You have to come across this gap right here. Okay, for the final resistor, we have the 10,000 ohm. Now this is going to go on your farthest emitter lead on your transistor. That's the one all the way to the right. And then the other side of this resistor is actually going to be shorted to this one. In order to do that, we'll just keep it in the same column on the same side of the breadboard. Now these two resistors right here are actually shorted together only on one side. So you have the 1000 ohm in the middle, the 10,000 ohm on the right, with the opposite side of the resistors shorted together. The second to last component we're going to put in here is the IR receiver. Now this is what actually picks up the flame and alerts and activates our alarm circuit. So go ahead and put this over here a little bit separated from the rest of the circuit. And I've bent mine this angle so I can demonstrate the flame. It's whatever angle you point your IR receiver. That's going to be the direction that'll pick up the flame. Now you are able to add additional IR receivers and you can kind of create a 360 flame detector. For simplicity, I'm just going to show you one direction here. And finally, we're going to use a 100 microfarad capacitor. Now this is actually completely optional in this circuit, but it does help to filter out the circuit a little bit, and it actually makes our buzzer just a little bit louder. Not all capacitors, but this particular capacitor does have a negative and positive side, indicated by this gray stripe here with the negative sign on it. So we're going to go ahead and insert this into our circuit, and the negative lead is actually going to go on the negative lead of the buzzer. The positive lead is actually going to come into the positive side of our circuit. So we'll plug that down here, where we'll jump in the positive power here in just a sec. Folks, that's it. That is all the components in the circuit. I told you it's super simple to build. Now, without any jumper wires, it's obviously not going to work. So I'll go ahead and insert the jumper wires and quickly go over what is connected to what. Okay, first, we're going to need to connect our negative side, which is the right lead of the LED, to the closest to the left lead of our transistor. So we will carefully insert that jumper in between negative side again of the LED into the furthest most left lead of our transistor. Now we'll obviously use the hole right in front of the used holes. I know it's kind of hard to see, but the gray jumper is between the negative side of the LED and the leftmost lead of our BC547 transistor. The next jumper we'll install will be from the opposite end of these two 1000 and 10,000 ohm resistors over to the IR receiver. So we just need a short jumper. We'll keep it in that same column, of course, which connects those two resistors. Due to my jumper length, I'm actually going to move this over one. Now for my IR receiver, I actually have it positive on the left and negative on the right. This is going to allow for long range IR operation. This is one of the tricks of this circuit. So again, my jumper is going from the opposite end of the 1000 and 10,000 ohm resistor, and it's tied over to the longer leg of the IR receiver. Okay, so we're going to wire in our buzzer. And to do that, we're going to wire in the negative side, which is the right side, to the negative side of the LED, which is also the right side. Now you can use any color jumpers you want. It just really depends on the length that you need. You can also create these out of solid core wires and make your own jumpers if you want. So just to show you, negative side to negative side of the LED. We're going to tie in the positive side of our buzzer. To do that, I've installed a jumper wire from the left side of the buzzer down to where the capacitor and the 470 ohm resistor is tied in for our positive side of the circuit right there. There's another look. Feel free to pause this video, zoom in to make sure you've got your circuit wired up correctly to this point. Okay, only a few more jumpers to go and we can try out our fire alarm circuit. Of course, we need to send power to the circuit. So this rail here, as you can see with the red line, this is called a rail, and this power supply here is going to send roughly 3.5 volts down the red side, so the inner side of this rail right here. Now this particular breadboard goes all the way across. Some of them you need to jumper in the middle. If that's the case, you can install a jumper right here and jump both sides of the rail so you don't have to work close to the power supply. Now we need to tie in the positive side for that resistor, the capacitor, and the positive side of our buzzer tie in. So we've plugged it in on that same column on this side of the breadboard, and we'll pop in the other side of the yellow jumper there, anywhere on that red side of the rail. So for a better look, we're tied in right there on the positive side of the circuit over to the red side of the rail. Now, of course, we need to tie in the other end of our IR receiver right here. And to do that, we're going to tie in the positive all the way over to the shorter lead on the right of the IR receiver. Now we used a jumper from one empty hole on the positive column on this side of the breadboard all the way over to the right side of the IR receiver. I recommend separating your negative and positive right here just by a few holes. And again, they are not in the same column. They are next to each other. I'll move this out of the way so you can see. As you can see, the brown wire is hooked in a little bit to the left, the gray wire to the right, and those are your two leads of your IR receiver. Okay, the last jumper we should need is to tie in the ground side of this circuit all the way up to the very right lead of the transistor. So we'll find an empty hole anywhere along this blue side of the rail as our ground, so it really doesn't matter which hole it comes out of as long as it's on the blue side and it provides provides the ground to the circuit. Now for simplicity, I'm going to come all the way from over here just so it's out of the way and you can see it better. So I'll make sure I stick it in the blue side, which is the ground, and I'll come over and find an empty hole on the very right lead of our transistor here, which ties in the ground for the whole circuit. Okay, so that last jumper we tied in from the ground all the way to the very right lead of that transistor, which will act for the negative side, the ground for our fire detector. Now feel free to pause the video right here so you can zoom in, kind of look around and see exactly how the components are working. If your fire detector doesn't work the first time, just double check the polarity on all these components. Just about everything in the circuit is on polarity except for your 3 resistors. Again, those can go in any direction. Make sure your transistor is facing towards you. The left side of the LED is positive, right side is negative. Again, with the buzzer, left side positive, right side negative. Capacitor, if you're using the same type as me, the positive will be on the right, negative on the left. Now, as far as the IR LED, if yours is only working close range, try flipping your leads on your IR receiver. That's what I had to do, and that just magnifies it so much you can go across the room with your flame and it'll pick it up. Again, if it's still not working, check all your jumpers. It's very easy to miss a hole and not line up stuff. A lot of this stuff is tied in together on the same column, so all that stuff has to be lined up or you're going to be missing a leg of your circuit. Okay guys, that's really that easy to build your own fire alarm circuit. Now this is a little bit more long range than a lot of them you've probably seen on YouTube. This will work actually anywhere. I've tested it up to 10 feet, still works. So we'll go ahead and give it a try. We'll flip our circuit on. You can see we have our green LED. This should be powered up right now. Everything does have about 3.5 volts on it. And as you can see, as soon as we light our lighter, it is beeping and the LED is coming on. And you don't have to be close at all. I will zoom way back, and as you can see, it still detects that flame, and it will detect it from very far away, all the way across the room. I just don't have a big enough space to show you that much distance. These IR receivers are pretty sensitive. If I were to come up behind, you could see it's actually picking it up from behind as well. Now it's always going to pick it up way better from the direction the IR receiver is pointed. That's why if you install multiple, maybe 4, you can have a 360-degree fire detector. If you tried this fun fire alarm breadboard project at home and you have any questions or just want to let me know how yours went, throw those in the comments below. I actually go through each and every comment in all my videos. Okay, if you guys found today's video fun and educational, please subscribe to the channel right here. It does something to the algorithm that lets it push out to many, many more people, so I appreciate that. And also, even more importantly, watch our next video right here.